This is a reminder Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class session for your own security reasons. So we are in the November 27th ticket. The link is in the chat box along with the password. I do need green checks all around, letting me know that you have that open. Again, if you're not coming to classes, you're not getting the passwords and you're not getting your 10% of attendance. Remember, this is the difference between a C and a D, a B and a C, an A and a B, right? It's really hard to get that extra grade to get that up unless you are coming to class. Plus, we do all of our assignments here. So if you block out the time to come here and do your assignments, it's super easy to get everything done. Right? Smiley faces if that makes sense to you, if you agree with that. All right, so we are in week 4 again, or sorry, week 5. We're on unit 4. Unit 4 is taking up our entire week. Today specifically, we're taking a look at atomic number and atomic mass, which we touched on a little bit yesterday. So this should be a super easy topic today. We're just going to review it, go a little bit more in depth. So again, we've been talking about the atom, its characteristics, 4 different terms that we should know really well by the end of class: atomic model, atomic number, atomic mass, and atomic nucleus. And again, at the end of this unit, we should understand all about radioactivity as well. So our objective for today, we should know the difference between atomic mass and atomic number, and we should be able to explain how atomic mass is related to the particles in the nucleus. Okay, remember all of the mass, it's concentrated in the nucleus. So that's where we're going. So quick review, guys. Smiley faces if you remember this from yesterday. Protons are positive, neutrons are neutrals, electrons are negative, right? We talked about how this idea of like pros and cons, pros are the good ones, so that's why it's positive. Neutrons looks like neutral. Tell me in the chat box, what is the charge of a neutral particle? What does neutral mean? Give me an actual number. What number means neutral? Awesome. I see an answer from Kendra, from Diego, from Andrew. Love the participation. Yeah, this is going to be 0 charge. Exactly. Thank you, Elijah. Thank you, Sienna. And electrons, remember we talked about if you get struck by electricity, that's a bad thing. So that is why these are negative. Now, again, they have very specific roles in the atom. Protons are related to the atom's identity. The number of protons tells you what the atom is, right? So if it has 3 protons, regardless of what else is going on in it, it will always be lithium. If it has 8 protons, regardless of what else is going on in that atom, it will always be oxygen. The element does not change as long as the protons stay the same. And we also call this the atomic number, which, again, today, that's part of our goal. We should really understand what atomic number means today. Neutrons, remember those are those neutral particles in the center here that help prevent our positive protons from repelling, because remember, opposites attract but likes repel. So these protons naturally want to repel. Neutrons help to buffer that and keep them from repelling. And again, electrons are the farthest thing out. They are not in our nucleus, right? The nucleus is protons and neutrons. The electrons are far out though, and because of that, they can connect up with other atoms and be involved in bonding. And remember, size-wise, neutrons and protons are much heavier. They each weigh 1 atomic mass unit, 1 AMU, whereas electrons are so tiny, we basically say that they weigh 0 AMUs because they're so teeny tiny. Okay, thumbs up if this is good, if you feel good about all this. This was literally a summary of everything we learned yesterday. We should know this super well now because this is going to set us up to know what we're doing today, right? We're kind of spiraling what we've been talking about. All right, so atomic number equals the number of protons, and it determines the type of element. So 2 parts. Atomic number is both the number of protons as well as the identity of the element. So again, the nature of an element is determined by its number of protons. It has a unique identity based on its number of protons. And again, we call the number of protons the atomic number. So let's say, for example, guys, that we have carbon with 6 protons. What would be its atomic number? Tell me in the chat box. If we have carbon with 6 protons, what is its atomic number? If they're the same thing, tell me in the chat box. Again, the number of protons is the same thing as the atomic number. So if we have 6 protons in carbon, what should its atomic number be? Yeah, exactly, guys, right? That should be super easy. Then it has an atomic number of 6. Okay, smiley faces if that makes sense, right? Again, this is really just a different name of saying number of protons, okay? Now, even if an element exists in a different form, think about the fact that carbon can exist as carbon gas. So for example, when we burn things, there's carbon gas. It can exist as pencil graphite, and it can exist as diamond. Think about the fact that what your pencil is made out of is actually the same thing as what diamonds are made out of. They're all made out of carbon, okay? But no matter what, even if they change forms, it always has the same number of protons because it's always carbon, okay? So it's always atomic number 6, 6 protons. Remember when I say element, I specifically mean something that we can't break down into a simpler substance, right? So if I take a bunch of carbon and I keep on dividing it in half, no matter what I do, it's still going to always be carbon. Okay, thumbs up if we understand that. Thumbs up if we understand that. Again, we can't break it down chemically into something simpler. Unlike water, water can chemically be broken down into hydrogen and oxygen. Okay, so this is number 1. Go ahead and give me a green check when you have that ready to go. You have 30 seconds. Fill in the blank with the word simpler. Go, go, go. Green checks all around, please. Jasmine, Joshua, Kyrie. Thank you, Siva. Waiting on Ty. Again, green checks if we have number 1 filled out. If you miss anything, it will be in the recording. Just make sure that you have the password saved because, like always, it's always a super rush at the end of class since I do have another class to go to. So please just make sure you save the password. That way you can, if you miss anything, it'll be in the recording when the recording gets uploaded later. Cool. All right, guys, so here we go. Have you ever been cutting a piece of paper with scissors and been worried that you might cut an atom in half and destroy the world? And this person replies, paper does not have atoms. Is that true, guys? What do you think? Do either of these people know what they're talking about? No, this is so bad, guys. Don't be this person, okay? Paper absolutely has atoms because paper is matter, and all matter, you, me, the air, paper, water, all matter is made of atoms. Okay, yeah, this is definitely super dumb. Smiley faces if this makes sense to you guys. Paper does have atoms. They are totally off their rocker. Cool. Plus the fact you're not going to cut an atom in half, right? To cut an atom in half, atoms actually have so much energy keeping them together that, again, if we were to cut an atom in half, it would definitely destroy the world. It would definitely cause an explosion, right? But we can't do that physically. There's like chemical processes where we have to bombard the atom with particles in order to make this happen. Okay? So that's not going to happen. Yeah, I think this is real. I'm really sad that it's real, though. All right, guys, so here's the deal. Remember, protons tell you the element. So if there's a different number of protons, that means it's a totally different element, right? So hydrogen will always have 1 proton. That's its identity. Hydrogen has 1 proton. 1 proton means an identity of hydrogen, whereas helium has 2 protons. 2 protons means an identity of helium. Okay, so if I change the number of protons, it's no longer hydrogen. If I change the number of protons, it's no longer helium. Smiley faces if that makes sense. Hydrogen, always 1 proton. Helium, always 2 protons. Doesn't matter what else is going on. The number of neutrons could change. The number of electrons could change. Crazy things can happen, but as long as the protons stay the same, the identity will not change. However, this is super important, guys. A single proton can make such a big difference, okay? Let's go ahead. I'm going to show you the difference between hydrogen and helium. Let me go ahead and grab this video. I apologize in advance because the audio quality is super bad, but just do your best. Go ahead. Give me a green check when you finish watching it.
Okay, so I have 2 balloons here. One's helium, one is hydrogen. Helium should not react, and the balloon will just pop. Hydrogen, on the other hand, will react. Does not react. The balloon just pops. Overcoming the activation energy, getting the hydrogen inside the balloon to react with the oxygen that's in air. Here we go. Ready?
All right, green checks. Oh, Kim, here, I'll go ahead and give you the link in the chat box. I can also give you the, let's see here. I'll give you the YouTube link as well so that you can watch it. Okay? Yeah, all right, guys. So what happened to the first balloon, the helium balloon? Tell me what happened to the first balloon, the helium balloon. Okay, what happened? Yeah, it just popped, right? Nothing super dramatic. It popped, which we figured would happen, right? When you heat it up, it's going to expand, it's going to pop. Absolutely. Now, what happened with the hydrogen balloon? The single proton balloon, a single difference in a proton. What happened with the hydrogen balloon? Yeah, it exploded in a fiery blaze, right? Smiley faces if you guys all observed that. It definitely was much different. Okay, so here's the thing, guys. Think about the fact that hydrogen and helium both make balloons float. Okay, they both make balloons float. But what do you think is going to be a better choice if you are making children balloons? Ariana, here's the YouTube link. Okay. Which one do you think is going to be better for children's balloons? Definitely helium, right? Because helium is non-flammable. Okay, so that single extra proton makes a crazy difference in the nature of the element. It changes it completely in how it acts in its identity. Yeah, exactly, Kim. So 2 protons makes it non-flammable, which is why we use it in balloons. Now, people used to use hydrogen because hydrogen is also really good at making balloons float, but this actually led to what's called the Hindenburg disaster. Okay, so what you can see down here is you can see an aircraft, kind of like a blimp, smiley face if you guys have ever seen or heard of a blimp, right? So you can see that right here. Okay, and what happened here is because this was filled with hydrogen, there was unfortunately, it got caught on fire, and because of that, it actually exploded, right? Which would have been very different than helium, right? Helium would not have exploded into flame. So we learned from this experience, and we learned that helium is a better choice than hydrogen. Yeah, crazy disaster. Okay, so not good. Okay, but that's why this is so important, right? A single proton makes a world of difference between hydrogen and helium. And that's true for every other element. Because of their number of protons, they act very, very different, right? Oxygen is something that we can breathe. Carbon is not something that our bodies can use. Sodium, right? Think about sodium and chlorine can be used in salt. So there are crazy, crazy differences between these elements because of their number of protons, because of their identity. Okay, now let's move on. Let's talk a little bit about atomic mass. Remember, atomic mass is the sum of protons and neutrons together. Okay, so let's talk about that. Again, to calculate atomic mass, all you need to do is add the number of protons, each of which has a mass of 1 AMU, and the number of neutrons, each of which has a mass of 1 AMU. Remember, protons and neutrons are where in our atom? Where are the protons and neutrons located? Tell me in the chat box. What is that part of the atom called where you find both protons and neutrons? Andrew, I see Sienna typing, Kendra typing. Love it. Please participate. Again, where are protons and neutrons found? Even if you see the answer, you should still answer because it helps to reinforce your own learning. Yeah, so they're found in the nucleus. Remember, all of our mass comes from that really dense, heavy nucleus, okay? The electrons, which are floating around outside of the atom, can be basically ignored because they're almost massless. Their mass is basically 0 AMU. So we ignore the number of electrons. Smiley faces if that makes sense. Okay, so what's floating on the outside of the atoms doesn't matter. All that matters is what is in the nucleus, the protons and the neutrons. Okay, now here's the thing. We can have elements that are the same element, but they have different masses because of the number of neutrons. Okay, specifically the number of neutrons, right? If I were to change the number of protons, would they both still be oxygen? If I were to change the number of protons, would they both still be oxygen? No, because protons are identity. So you can see here that in this case, oxygen, both of these oxygens have 8 protons because if we change that, they would no longer be oxygen. okay? But I can change the number of neutrons because neutrons have nothing to do with identity, right? They don't change the atom's identity, right? So we can have oxygen with 8 protons, always must have 8 protons, but in this case has 8 neutrons. Okay, so let's figure out what the atomic mass is. Again, all we need to do is add the protons and neutrons together. So what's 8 plus 8? Tell me in the chat box, what is 8 plus 8? Go ahead, get that in the chat. Awesome. We know math. I like it. 8 plus 8 is going to give me 16 AMUs, or 16 atomic mass units. And so this is why we call an oxygen atom with 8 protons and 8 neutrons, we call this oxygen 16. Okay, so this is the isotope oxygen 16. Again, it's a variation based on the number of neutrons. Now, let's try a different isotope, oxygen, again with 8 protons, must have 8 protons, but this time with 9 neutrons. What is its atomic mass? Again, add those together, 8 and 9. What does 8 and 9 give me? I have an extra neutron, so what is my mass here? Extra neutron, so what is my mass? Need more answers than that, guys. I know all of you know what 8 plus 9 equals in the chat box. 8 plus 9 equals what? Let's get your answers in there, please. I see Andres typing. I see awesome Kim in the chat box. Love it. Yes, 8 plus 9 is going to give me 17 AMU. So what do you think I'm going to call this? If I called oxygen with 16 AMUs, oxygen 16, what do you think I'm going to call this isotope? I got 2 answers. Are we sure? Are we not sure? What am I going to call this isotope? If 16 AMUs gives us oxygen 16, what does 17 AMUs give us? Yeah, it's going to give us oxygen 17. Awesome. Smiley faces, guys, if this makes sense. Smiley faces if this makes sense. This is a little bit of math, right? But it's super easy math. Just take the number of neutrons, number of protons together. Cool. All right, guys, so here's the thing. When we change neutrons versus changing electrons, a couple different things happen. However, in both cases, changing the number of neutrons and changing the number of electrons does not affect the identity of the atom, because identity is only based on what? Again, for like the 5th time, identity is only based on what? In the chat box, identity of an atom is only based on its what? Yes, on its protons. So if we change neutrons, change electrons, it has no effect on its identity. It's still the same atom. However, it does change a couple characteristics, right? So neutrons, right, they do change mass. Remember, neutrons have mass. Therefore, if you change the number of neutrons, you change the mass. But neutrons, do they have a charge? What's the charge of a neutron? What's the charge of a neutron? Yes, it's 0. So the result is, if you add neutrons, doesn't matter if you add 100 neutrons, it will never change the charge of the atom because you're not actually adding any charge. They're neutrally charged. Okay? And again, this is what we call isotopes. Changing the mass results in different isotopes. So for example, protium isotope is hydrogen with 1 proton and 0 neutrons. Tell me in the chat box, what would be the atomic mass here? 1 proton, 0 neutrons. 1 plus 0 equals what? 1 plus 0 equals what? Yeah, let's try and go ahead and include those units as well. I see Kendra did that. I see Sienna did that. Awesome. Yes, this is going to be 1 AMU. Love it. Okay, so that's going to be hydrogen 1, which we also call protium. Now, deuterium is hydrogen with 1 proton, 1 neutron. What's its mass? Love it. I love seeing those units. Yeah, this is going to be 2 AMUs. So again, we would call this hydrogen 2, or its more, what do you call it? Its regular name is deuterium. Okay? So smiley faces if this makes sense. Again, no change in identity. It does change mass, but does not change charge. And again, we call this an isotope. Okay? Awesome. Now let's do the same thing with electrons. Again, electrons, no effect on identity because electrons are different from protons, and protons are the only thing that affect identity. Okay? However, electrons, do they have mass? Do electrons have mass? Tell me in the chat box. Think about, they're on the outside, they're super tiny. No, they basically have 0 mass, right? So they're basically 0 AMUs. So they're not going to change the mass. Again, same thing. We can add 100 electrons and it's not going to affect the mass of the atom. However, electrons, what is the charge of an electron? Okay, we've got +1, 0, -1. What is the charge of an electron? Yeah, it's going to be -1, right? So it has a charge of -1. Okay, whereas remember, our neutrons had a charge of 0 because they're neutral. Okay, so adding electrons definitely changes the charge, right? More electrons means it's going to become more negative. Less electrons means it's going to become more positive. So it definitely affects the charge. And when we have a different number of electrons, this is what we call an ion. Okay, so if you think about ionization, that means that we are actually changing the number of electrons. Smiley faces if that makes sense. Okay, so again, isotopes are different neutrons, ions are different electrons. Okay, so let's say, for example, we have a sodium ion with 11 protons and 10 electrons. So again, protons, are they positive or negative? Protons, are they positive or negative? Think again, pros and cons. Pros are what? Positive or negative? Yes, they're definitely going to be positive, okay? So 11 protons gives me 11 positive charges, okay? Now, 10 electrons, remember electrons are negative, so this actually gives me negative 10 charges. And let's put those together, guys. What is positive 11 and negative 10 together? What is positive 11 minus 10? Positive 11 minus 10. Yeah, it's going to give us a charge of 1. This is not AMU, guys. Actually, charges don't really have a unit, right? So the charge is just positive 1 charge. Okay, smiley faces if that makes sense. Okay, it's not the same units because this is not mass, right? Atomic mass units doesn't make sense to put that with charge. All right, cool. Now, an oxygen ion, okay, let's say this time for an oxygen ion, we've got 8 protons, which is positive 8, and 10 electrons, which is negative 10. What's that going to equal? Okay, again, we've got positive 8 minus 10. What is our overall charge of our atom, of our oxygen ion? Yes, you guys are totally correct. This is going to be negative 2 charge. Negative 2 charge. 8 minus 10 equals negative 2. Okay, smiley faces if you feel good about that math. We did a couple practice problems together. There is going to be a question in your quiz that asks you to do something similar to this. So again, you'll need to pay attention. Are we talking about mass, in which case you do the protons and neutrons, or are we talking about charge, in which case we do the protons and electrons? Okay, thumbs up if you guys feel like you can do that. Okay, thumbs up if you feel like you guys can do that. Okay, awesome, super easy, cool. All right, let's go ahead and match these up. So I want to know what happens when we change neutrons, change electrons, or if we change either of them, right? So go ahead, you're going to match these up. You have your whiteboard tools. Again, what is the effect of changing neutrons, changing electrons, or changing either of them? Okay, both changing neutrons and changing electrons has the same effect. Okay, go ahead, match those up. 10 seconds. 1, pause. Oh my gosh, guys, give yourself a round of applause. This looks perfect. I'm going to go ahead and clean it up, though, just so that we have it ready for our question number 2. All right, so yeah, changing neutrons, again, all this does is change the mass, and these are what we call isotopes. Awesome, that looks great. Now, if we change the number of electrons, remember this changes the charge, and this is what we call ions. Awesome. And lastly, regardless of if we change electrons or neutrons, it will still be the same element because the element is only related to protons. So as long as the protons stay the same, it's not going to affect the identity. Smiley faces if that makes sense. Smiley faces if that makes sense. No matter what you change, if you're not changing protons, it's not changing the identity. It's still the same element. Awesome. This is number 2. Go ahead and give me a green check when you have number 2 saved. You guys have 45 seconds. Green checks when you're ready. Go, go, go. Waiting on a few more green checks. Adriana, Annalise, Dalen, Destiny, Jacob, Jasmine, Joshua, Kyrie, Melissa, Ty. Again, I mentioned it in the chat box, but if you guys ever feel like you're in a crunch for time, totally fine. Just take a picture, make sure you write down the password, and then you can always go back to it later. Just always make sure you write down the password. Even like right now, guys, even if you're like, I'm doing the attendance ticket, you should still write down the password because sometimes K-12 website does crazy things and you don't want to lose your work, right? So always write down the password. Cool. All right, guys. So again, this is our periodic table. I had a picture of that right here, right? So we can see our periodic table, and if we zoom in on one of our squares, like carbon, again, there's a lot of really important information here, right? We can see the symbol, we can see the name of the element, and we can see the two things that we talked about today. Atomic number, which is the number of protons and its identity, right? So this is the number of protons and its identity. This symbol here means number, not hashtag. Okay. And then atomic mass is both the number of protons and the number of neutrons together because it's the mass of the atom. And again, protons and neutrons are the only thing that contribute to the mass of the atom. Okay? Now, here's the thing, guys. You can see atomic number is a whole number, right? There are 6 protons. You can't have half a proton. Smiley faces if that makes sense. Okay, atomic number is always going to be a whole number. It's always going to be a perfect number. Okay. Now, on the other hand, atomic mass, is atomic mass a perfect number here? Is it a whole number here? Tell me in the chat box. Is this a whole number for atomic mass? I'm pointing at it in the picture here. No, 12.011 is definitely not a perfect number, okay? Which kind of doesn't make sense to us, right? Because if mass is the number of protons and neutrons, and I can only have whole numbers of protons and neutrons, then the mass should be a whole number. Okay, but the issue here is atomic mass is not a perfect number because it's actually an average of all the different types of isotopes, right? So there's actually carbon 12, which 6 protons, 6 neutrons. Carbon 13, still 6 protons because it's still carbon, but this time has 7 neutrons. And carbon 14, which has still 6 protons, but this time 8 neutrons. Okay, so these are all the different isotopes of carbon that exist, okay, in our world, right? And so because they exist in this amount, we take the average of all of them, and that gives us the atomic mass. Give me a smiley face if that makes sense. This gives us the atomic mass by averaging these out. Okay. Now, this is actually what we call a weighted average because the one that exists more is the one that the number is going to be closest to. So taking a look here, okay, carbon 12 exists the most. Okay, it's 98.9% of carbon, and that's why the atomic mass is closest to 12. Carbon 13 and carbon 14 don't contribute a lot to the average of masses. Thumbs up if that makes sense. Okay, so the number is closest to the isotope that's most common. So the mass is closest to carbon 12 because carbon 12 is the most common. Awesome, guys. Cool. All right, so now taking a look at our periodic table, we should really understand what our periodic table tells us. We should definitely know atomic number, protons and identity versus atomic mass, the mass of the protons and neutrons together in the nucleus. Cool. All right, let's match these up. Let's make sure this makes sense. Again, number versus mass. Go ahead and match those up. Let me know that you understand the differences between these two things. Fingers crossed. Love it. Looking good so far. Oh, you guys are so on top of it. I love it. Take another 5 seconds, and then I'm going to pause your tools. Awesome, guys. You totally did this perfectly as well. Give yourself a round of applause one more time. I love it when we're successful, when we're learning. All right, let me go ahead and match these up. So atomic number, yes, atomic number tells us the number of protons. And again, atomic number is the element's identity. The number of protons is the identity. Awesome. Now, atomic mass, on the other hand, atomic mass is the sum of adding protons and neutrons together. And again, it does not include electrons. Tell me in the chat box, why does it not include the mass of electrons? Why does it not include the mass of electrons? Yeah, exactly, Sienna. They don't really have mass, right? There's 0 AMUs, so we can ignore them because they're basically massless. Okay, this is number 3 in your attendance ticket. I'm going to go ahead and give you 45 seconds. Green checks when you have it saved. Go, go, go. Waiting on a few more green checks. Annalise, Dalen, Demetrius, Frankie, Jacob, Jasmine, Joshua, Kyrie, Kevin, Melissa, Ty, and Zoe. Oh, looking good. All right, guys, so remember we talked all about atomic mass versus atomic number today, so you should feel super comfortable with that. But even if you don't, remember all of the attendance ticket answers, all of those yellow boxes are also what you need for the quiz answers, okay? They're the same exact information that your quiz asks you about. So just have them open side by side, and then once you're done with your quiz, you can submit them both at the same time. Smiley faces if you understand what I expect you to do. Again, all of the answers are in the yellow boxes that we just filled out in our attendance ticket, so just do them side by side and then submit them at the same time. Awesome, guys. So that being said, here's what we've got. Here's our last word, and I will see you all later. Bye, everyone.